Alright, so continuing on from the last video, what we need to do is finish off and add the code to the static initializer block to process the exits, the directions. So we're going to do this below the first try with resources block. So we're going to do it down there, and we're going to start with try, and it's going to be buffered reader. dir file equals, it's going to be files dot new buffered reader again, and dir path this time. Then we're going to do string input, and while input equals dir file dot readline, well, that's not equal to null. And I got the parentheses slightly wrong with that. It should be one parenthesis at the end of the line and an extra parenthesis to the right of the dir file.readline. Alright, so then we're going to do a string array. Data is equal to input.split, comma. Then we're going to do int lock is equal to integer dot parseInt. It's going to be data 0. First element, so string, then direction equals the second element, so it equals data 1. Then int destination is equal to integer dot parseInt, and the next element data 2. Let's just print those out then. So I'm going to print out lock plus colon plus the direction plus another colon, space, then plus the destination, just so you can see that it is being retrieved okay. And next we want to create a location, so location equals locations dot get lock, so we're using that as the key to get it, the lock, the first element that we retrieve for the location. Then we want to add some exits, so location dot add exit, and that's going to be direction destination. Okay, and then to get rid of that other error at the top, or both errors, we need to catch the IO exception. And we need another right curly bracket there, catch, and e.print stack trace. I'll just tidy that up. Okay, and of course that should have been new buffered reader, because we're reading, not writing. Okay. And I seem to be having a bad day with coding. I've got an extra one in there. So I'll just reformat the code again. And it should be good to go. Nothing needed to be changed. Okay. So even though we typed in a lot of code, really the only thing we changed here is the files.newBufferedReader method call in both try statements. Also, we had to declare the two path variables. Otherwise, the code's pretty much identical to what it was when you called the buffered reader constructed directly in the two try statements. Now, as mentioned before, when you use the files.newBufferedReader or writer methods to create the buffered reader and buffered writer, the underlying instance used to do the I/O is a java.nio instance rather than a java.io instance. Alright, so what about reading and writing objects? Well, firstly, there isn't a files.newObject input stream or files.newObject output stream method, but there are new input stream and new output stream methods which return an input stream and an output stream respectively. So in other words, you can construct an object input stream from an input stream and an object output stream from an output stream. So with that said, you should be able to create an object input stream or an output stream from a path using a two-step process. So you call the files method to get the appropriate stream, and then call the object input stream or object output stream constructed directly using the stream you got from the files method. Sounds like a mouthful, but let's actually try that to see how it works. Alright, so this time we're going to be writing and reading the locations.dat file. Now you no longer need two files because you're going to serialize the contents of every location object to the locations.dat file. So to do that, we need to go to our locations.main method to write the file. So I'm going to go back up there. So we're in locations and looking at this main code. So what we're going to do here is we're going to just comment this code out to show you how to do it using objects. So we're going to comment that out entirely so we've got a copy of it. And I'll actually start coding it at the top. Alright, so again we're working now with the locations.dat. So I'm going to start by typing path. Lock path is equal to file systems dot get default dot get path. And this time, as I said, it's locations.dat. Then we just do a try. We start with an object output stream. Lock file is equal to new object output stream. Then we do a new buffered output stream. And then we pass to that the files dot new output stream. And for location path. And then in terms of writing it out, it'll be code as you've seen before. So for location, colon, locations.values, lock file dot write object, location. So two things to notice with this code. First of all, you're using the files.newOutputStream method. This one up here on line 21. We're using that to get an output stream using a path instance. Because it's passing lock path, and of course that's using the path, the java.nio path object, or path instance I should say. And secondly, what we're doing is exactly what we did when we created a file output stream using the file output stream constructor. So you're wrapping it up still in this buffered output stream, so the IO will be buffered. Then you're wrapping that in an object output stream. So really the only change you've made is the code, or to the code, is to call the files.newOutputStream rather than the file output stream constructor. So that's where the java.nio code comes in. Alright, so we've got an existing locations.dat file. If you wanted to, we could delete it, but we're just going to run it again and it should be recreated. So let's run that. Okay, the code is has been written. And the static initializer block also was executed, which was in case you're wondering where that output come from. Obviously, we didn't have any output here for locations.dat while we were creating that. All right, so now that we've done that, let's now modify the static initializer so that it uses the files.newInputStream. So let's go down and have a look at that. And the code is going to be a lot easier because we're reading objects instead of reading it and using delimiters and so forth to retrieve the data. So I'm going to copy that or comment that out and let's have a look at it. The code to do that now, path, lock path is equal to file systems dot get default dot get path. This time it's locations.dat, which we've just created in the main method for the locations class. And then we're going to do try, and it's going to be object input stream this time, and lock file is equal to new object input stream this time, new buffered input stream, then files.new input stream lock path. Alright, then let's write the code now to get the objects. Boolean EOF equals false. And then we do a while, not in the file. We want to try there, and we're going to catch the end of file exception. And we'll put EOF equals true for that caught exception. And the code in here is going to be location equals cast that as a location, lock file dot read object. And then we want to do locations dot put location dot get location ID, comma location. And we've got another exception that we need to catch here, and another one here, because if you remember the code when we've done this previously, we had a number of exceptions. We do a catch. This one is invalid class exception. If we get that, we'll just print out a message. Valid class exception plus e.getMessage. We could have just printed out the stack trace if we wanted to. We also want to catch the IO exception. Right, and print out the message as well. And then the third one we do want to catch here is the class not found exception. Class not found exception. And that was going to be class not found exception e.getMessage. So the code is very similar, almost identical to what we used previously to read objects from locations.dat, except we're using the files.new input stream up here on line 51, using that method to create an input stream, and then we're wrapping that with a buffered input stream, and then we're finally wrapping that with an object input stream. Okay, so if we run that, we should find that our code still works. And obviously we're not getting any errors, which is a good thing. But we're also not getting any output anymore because we didn't put any debugging code in our main code, but also not in our static initializer block either. So essentially you can use files.new input stream and files.new output stream to create any stream that descends from input stream and output stream respectively. Alright, so at this point you now know how to use java.nio classes to create commonly used java.io streams. In the next video we're going to start looking at how to read and write text files using java.nio exclusively. And if you recall a few videos ago I said that doing IO using java.nio means that data is processed in blocks rather than one byte or character at a time. So to accomplish this, java.nio uses channels and buffers and sometimes selectors. So let's start looking at channels, buffers and selectors and figuring out how to use java.nio to do all our I/O in the next video.